This is the outline for chapter 28. So we will first introduce about the B field. The B field actually it should be the magnetic flux density. Magnetic flux density should be the B field. Actually, the magnetic field should refer to the H field, but in this textbook, it just called B field the magnetic field. But for some other material, okay. It should be B field should be the magnetic flux density. Okay, and then we will discuss about the cross field. Okay, so to talk about the discovery of electron, and then we'll talk about the Hall effect to verify that the charge carrier in the conductor should be negative rather than a positive charge. Okay, and then we'll talk about the circulating charge particle. Circulating charge particle. So a charge particle entering a B field. Okay, and then it will do circulating. It will have a circular motion. And then we will talk about two kind of particle accelerator. One is called the cyclotron and another one is called the synchrotron. And then we will talk about the magnetic force on a current carrying wire. Okay, so yeah, it is actually a kind of Lorentz force. Okay, at the very beginning we will talk about the Lorentz force here. Okay, but the magnetic force acting on a current carrying wire is another point of view for the Lorentz force. And then finally, we will also talk about the torque on a current loop, and then the magnetic dipole moment. Actually, previously you have already seen the electric dipole moment. So a magnetic dipole moment is a similar variable. Okay, for the B field. Okay, so here we assume there's a B field. Okay, so the B field. Actually the magnetic flux density. Okay, I don't try to repeat it again. So I don't try to modify it because there are too many. So later on, okay, when you see B, it should be magnetic flux density. Okay, so we assume that if there is a B field or generated by some structure, okay, we don't try to talk about how we can calculate the B field magnitude or how to calculate the B field in any sense. Okay, in the next chapter we'll talk about how we can calculate the B field due to some charge movement or some current, something like that. Okay, but here we just accept that there should be something called B field exists in the world. Okay, so in that sense, here we try to discuss when a charge particle entering the B field, or what will be the interaction. Okay, so here the equation is like FB equals Q times V cross B. Okay, so this is the cross product. And then the Q is the charge amount you are familiar with. And then V is the velocity of the charge particle, and then we have it cross with the B field. Okay, so here we have a V cross B, and then multiplied by the Q to become FB. Okay, so cross product is an operation similar to the dot product, but it is a little bit different. For the dot product, you have two vector to act on the dot product so that it becomes a scalar. But here for the cross product, you have two vector for the cross product, and then finally the outcome become other vectors. Okay, so but first we try to consider the magnitude. Okay, so this is the vector form, and then we try to consider the magnitude at this case. So here we take the absolute value of Q and then V times B, and then we have this sine of theta, okay, for the cross product. So this phi is the angle between the direction of the velocity and the B field. Okay, so for the dot product, it is the magnitude of the two vectors multiplied by cosine of theta. Theta is the angle between them, and here we have a cross product to be the magnitude of the two vectors multiplied by the sine of phi. Phi is the angle between them. Okay, so you need to memorize it. And okay, so first we talk about the magnitude, and then the most difficult part is the direction. Of course, you may have learned the cross product in high school physics. So actually, we'll use the right-hand rule, 右手法则 to determine the direction of the cross product. Okay, it will be something similar. Similarly speaking, okay, if we have a vector v like this and then vector b like this. Okay, so first you try to take out your right hand, and then you use your forefinger pointing to the first vector. Okay, the order of the cross product is important. Okay, so v cross b and b cross v are different. Okay, it has a negative sign in between. Okay, so it means v cross b and b cross v are different. Okay, it is equal to negative. V cross b is equal to negative b cross v. Okay, so you need to pay attention to the order of the cross product. You cannot exchange the order. Okay, so you use your forefinger pointing to the direction of the first vector. This case is v cross b. Here we try to consider v cross b. Okay, so you try to use your forefinger, follow the direction of v, and then you swing it to the second vector direction. Okay, so your thumb will point to the cross product direction. Okay, so which means that this is the direction of v cross b. V cross b. And what we need to be careful is that this angle phi should be between 0 degree and 180 degree. It cannot be larger than 180. Okay, you cannot do it like, oh, I do it like this, and then I swing it for more than 180 degrees so that my thumb point to the opposite direction. It is not correct. So you make sure that, yeah, this phi should be between 0 and 180 degree. So in that case, we already know how to determine the direction of a cross product. So finally, for this so-called the Lorentz force, okay, it of course has this cross product. So finally, you just take a look at this polarity of the charge. If it is positive, then FB have the same direction as the V cross B. If Q is negative, then FB points to the opposite direction. It's just that easy. Okay, so let me stop here.